Hello, everyone, and welcome to one more day of Advent of Code in Kotlin. It is day 5, another work day this time around. Yeah, so hey everyone. If you are around, make sure you say hello as usual. And I mean, by now, if you've tuned in a couple of times, you know the drill. I'd love to hear what you thought of today's problem. Couple of opinions. And while you type those out, I can tell you a little story about my cup that I have today. Today's cup is a Slack cup, which comes from a time when Slack decided it was a good idea to just host a party for all the people who were admins of a Slack workspace. In my case, that was here in Munich. It was like a physical party, and they created like a little Christmas market with the glue wine and punch and like candy and stuff. It was very nice. You don't see that often anymore. I feel like. I wonder why. Guess the VC money runs out eventually. I'm just happy to be back. It's gonna be another wonderful day. Have a couple of hellos. That was nice. Jonathan says the problem itself was easy, but I messed up the directions multiple times, which cost me. Yeah, fair enough. That's a classic one. I guess we can add it to naming, cache invalidation, refactoring, and order. I think is that like the new one now as one of the big problems. Running over a stack the wrong way around or a list and screwing around with indices is always a fun time. Yeah. Wonderful. Baptist asks, can anyone tell me how to disable Git annotations in my code in IntelliJ? I don't want to see those. I can try. We can take a quick look. I believe those are called... I'm going to try to pull this up before, and then I'll just share my screen real quick. I think they're called inlay hints. Yes, so let me just pull that up real quick for you here. Look at that. If you look for inlay hints, there's something called code author, which I guess is the one that you probably don't want to see. So you unclick this one, and you're not going to see that one anymore. Hope that one helps. Yeah. Let's see here. Saboba Fett says, I accidentally solved part 2 before part 1. Again, that's, yeah, that sounds like you got the order the other way around. Olaf is very happy that he finally got something to visualize, which is also nice. If you do have a visualization, if you do have something nice that you would like to be shown on stream, Olaf, send me a DM on the Kotlin Lang Slack, and I'll pull it up on stream, and we can look at that later. STU says I need my coffee. Yeah. I think sometimes we really all need those. 45 minutes to parse the input, 5 minutes to do part 1, and 1 minute for part 2. Yeah, that's one of the big ones. This one is all about parsing. Yeah. So we're definitely gonna take a closer look at all of this. I'm just gonna pull up the my Slack here on the other side in case I get anything. I'll put that here. Day 5 was big setup. Yeah, it was. Okay. Well, of course, today we are not alone. I am joined once again by a wonderful new guest. Our guest today, I'm here, is Akshay, who's a senior Android engineer at Tinder, and also a Google developer expert for Android and for Kotlin. Hey Akshay, how are you doing?
Hey Sebastian, I'm doing great. How about you?
I am wonderful. Advent time is always really special to me because I get to do these challenges, and it's one of those things where at least in JetBrains everyone kind of comes together, and like there's people discussing from all kinds of areas about the problems and about solutions, which I usually really enjoy, and I also enjoy getting like texts at 5:55 in the morning that say like good luck for today. I don't know, it's a nice ritual for me. Yeah.
Yeah, this is my first time doing Advent of Code, and yeah, I agree with you. It does sound fun, and for some reason I feel like it's kind of like Christmas for me, in a code way. So yeah, it's fun.
Yeah, it really is like this, you get like a little present every day to unpack, a little nut to crack, I guess.
Yeah.
Yeah. So this is really good. So you say this is your first time doing Advent of Code. I always say Advent of Code is a time for firsts, right? So even if it's the first time for Advent of Code, it's a nice meta way of covering this.
Yeah.
Yeah. So, but I assume this isn't your first time solving coding problems or like coding puzzles specifically, right?
Yeah, that's true.
Like what kind of other stuff did you do beforehand? Were you doing like lead code problems or something in that regard, or kind of where were you going?
Yeah, I used to do a mix of those, like, so lead code for sure. And sometimes in my previous company, uh, they used to share some like puzzles like this way, which were sometimes like used by Google. I think like they just took from what Google shared and like gave it to us just to crack, just for fun. I think that was like for freshers. But yeah, I think that was when like I used to play around. And yeah, again, like job interviews, lead code, stuff like that was always there.
See, yeah, we had Todd Ginsburg on the show yesterday, who actually mentioned that yesterday's problem was quite similar to what they were using to interview candidates. So he had a pretty good and a pretty neat solution ready, almost from the get-go. Which of course is a nice home field advantage, right? But it also shows that your, I guess it goes both ways. Your lead code knowledge or your interview preparation knowledge translates nicely into Advent of Code, and your Advent of Code knowledge translates quite nicely into at least some preparation for interviews, I would say as well.
Yeah, I agree.
Okay. Just generally, how did you feel about today's problem, without going into the details just yet, but like just from the vibes?
Yeah, initially, like, I really like the problem statement, like, in general, like, even on lead code, and all these puzzles, I like how they phrase the statement and how they come up with these problems, like this one, like start with the storytelling that, oh, they want to move from one crate to another,
Yeah.
and how they like build up the story. I really love that part. And in this one, they did the same. So yeah, that's pretty nice.
Yeah. Which is also why we are going to actually do a little bit of a dramatic reading of this. So I'm gonna put on my reading hat.
I like your reading hat.
Thank you
I
very
need to
much.
get one too.
Yeah, it's excellent. I'm also looking to get like some reindeer antlers. But the problem is, and I don't know what's up with this, so usually I'm a little bit spoiled, right? Because I live in a big city, which means I usually can, if I really need to, I can get stuff like with Amazon Prime the next day or maybe 2 days later. All of these, they said like the earliest they can deliver them is like by the 11th, which is crazy to me, because by that point we're probably not sure if we're still gonna have streams. So yeah, we're gonna have to go with the hat that I'm running with right now. Okay.
Yeah, I like this one.
Yeah,
I think it's better.
it's a delightful color if you ask me. So okay, day 5, supply stacks. The expedition can depart as soon as the final supplies have been unloaded from the ships. Supplies are stored in stacks of marked crates, but because, and I actually should probably pull this up. Here we go. Supplies are stocked in stacks of marked crates, but because the needed supplies are buried under many other crates, the crates need to be rearranged. The ship has a giant cargo crane capable of moving crates between stacks. To ensure none of the crates get crushed or fall over, the crane operator will rearrange them in a series of carefully planned steps. After the crates are rearranged, the desired crates will be at the top of each stack. The elves don't want to interrupt the crane operator during this delicate procedure, but they forgot to ask her which crate will end up where, and they want to be ready to unload them as soon as possible so they can embark. They do, however, have a drawing of the starting stacks of crates and the rearrangement procedure, your puzzle input. For example, we have these 3 stacks that contain elements Z on the bottom and N on the top. Stack 2 contains 3 crates. From bottom to top, they're M, C, and D. And finally, the third stack contains a single crate, which is P. Then the rearrangement procedure is given. In each step of the procedure, a quantity of crates is moved from one stack to a different stack. In the first step of the above arrangement procedure, 1 crate is moved from stack 2 to stack 1, resulting in this configuration. Yeah, we got 1 crate moved from stack 2 to stack 1. In the second step, 3 crates are moved from stack 1 to stack 3. Crates are moved 1 at a time, so the first crate to be moved, D, ends up below the second and the third crate. So this is, so we'll find that D is at the bottom, and then N and Z are stacked on top here. Then both crates are moved from stack 2 to stack 1, again because crates are moved 1 at a time. Crate C ends up below crate M, and then finally 1 crate is moved from stack 1 to stack 2, so we end up with this final configuration. The elves just need to know which crate will end up on top of each stack. In this example, the top crates are C in stack 1, M in stack 2, and Z in stack 3. So you could combine these together and give the elves the message CMZ. After the rearrangement procedure completes, what crate ends up on top of each stack? All right, Akshay, what are we thinking about this problem?
For sure, like we will need. So my initial thought was like using like for sure stacks or some sort of a DQ to access to put all these elements on top of one another. And to parse, I was thinking about regex initially, like using so we also need to like be aware that all these elements, like, so when we read the file or read this input, we'll be reading like line, like we'll be going horizontally, right? But we need to be also aware that there are like stacks 1, 2, and 3. Like we need to be also aware about this vertical dimension. So and put these values in the right stack number.
I think people said beforehand that this one really felt like it was mostly parsing the input, which I agree. I mean, this does look pretty funky, and if we look at the actual input that we have here, we can also see it's a little bit bigger still. You've got a lot of these stacks, and you got them in these awkward positions where you can't really just split on a character, because you might just be hitting a couple of spaces until you get the next one. So there's definitely a little bit of a trickiness to this one, just from the parsing perspective. Okay, cool. Then let's switch over to IntelliJ Ideas. So last time I did get the request again from people who said they had an easier time reading in the light scheme. So we are back in light scheme. Flashbang warning for everybody. Yeah, of course I know that some people prefer the version that's dark, but yeah, generally I think on the eyes it's easier for people to read with this one, at least at lower resolutions. Okay, cool. So actually let's start. I think we're gonna start at the main method, and then you can just kind of walk us through step by step what's going on.
Yeah. So like you also said, Sebastian, like this puzzle is all about like a lot of parsing involved. So we do the same. Like, so we first like we read all the lines in the file. And there are like also I realized there are like two steps we need to do. One is like creating the stack, basically having all those all those values in a stack, and the second part is knowing which crate goes where, so which is like the moves. I call it as moves part, and that's how like I divided this problem into two things. So one is like as you see on line 64, we are like calculating the number of stacks we need to create, and we are using like array-dq to store the values of the stack in there. So like it maintains the stack principle where like the last value is at the top, so we can like get it as a first one when we want to give the elves which one is which stack is at the top. And then as a second step we do is like once we create all the stacks, we fill them with the values.
Okay, so let's go through step by step maybe and see kind of how you're even how you're parsing the numbers and so on. So let's jump up here. So this one, so I see that your function, this takes in the whole input, is that correct?
Yeah, that is correct.
Okay. And then walk us through this call chain.
Yeah, so essentially, like you said, like we get all the lines, and since we just want the number of stacks, we can go with a drop while instead of a filter, because drop while will like drop the last one. So we just say all the lines which contain the starting bracket, which is essentially all our input till we hit the number like 1, 2, 3, 4, which is the numbering for the stacks. Once we get that, we essentially have all the lines. Then since we just want to get the count, we just like get the first one, split all of them by a space, and we check if it is blank or not, and then we get the maximum integer out of that list.
Okay.
And because since the maximum will tell us like how large the stack of how much memory we should allocate for a stack, and that will be the maximum, right? Like it won't exceed any out of that.
Understood. Okay, so this is, let's go back down here. You're essentially just getting your number, which is I think it was 9 for everybody, but I'm not sure. You get your stacks here, and you are just creating collections for each one of them.
Yep, that is
okay.
Correct.
And then here we have another fun function, which even takes a lambda. So before we look at this call, let's actually look at the function implementation itself. Walk us through this one.
Yeah. Yeah. Let me remember this one. Yeah. Oh, yeah. This is the same. We are sort of doing the same thing, but now what we do is like here again, like we get all the lines, we filter them with the bracket, so we get only the ones which are stacks, and then we take each line and we check in there if there is a character, and whenever there is a character, whenever we like for each line, so let's say we start with the first value, we take the one, we slowly go on like character by character horizontally, and then whenever we hit a letter, we stop over there, and that is like line 50. And what we do over here is we get the value on line 51, which is like the number like 2, 4, whatever is in there.
Okay.
No, oops, my bad. Is the reverse. We get the letter over here like C, Z, M, whatever is in the crate.
Sure.
And the index divided by 4 is actually the spacing. So this is kind of like I did like in hard coding over here. I was wondering if there could be some other way, but I ended up doing like a white space hard coding. So essentially, like whenever there is I noticed a pattern that whenever there is a letter, there's always a spacing of 4 white spaces, like trailing white spaces essentially.
Yeah.
So that's how I use it to calculate the index in which stack index it will go on.
Yeah, this is I like this. This is a clever move. I've also seen someone in chat mention. Let me find this one again. It's the human bomb. Does the map using a step of 4, which is also clever. So instead of going through each character, they straight up go for a larger step size, which is a cool move. I like that one as well. Nice. Okay, and then whenever a character is found, then the lambda is called up here. Okay, and I guess the concrete lambda that we have in this case is this one, where you just take the stack number and the value, and you add it on top with the structure that you've built previously.
Yeah, that is correct.
Okay. And then the second part before we can execute is the moves. So this one you actually do kind of, no, you don't do it inline. You have this wonderful move off function. That's very cool. I guess this is a pattern that we see in Kotlin quite a lot, but if you want to briefly explain this, I'm assuming this is a companion object function.
Yeah. So yeah, this is a companion object function, and this pattern is like helpful if you want to create the object of your class like with a different parameter. Like for example, now here if you look at our data class move, it requires quantity, source, target, and you don't always have that, right? And you might have a different type of data, and so essentially like you're exposing a function to allow to create this class from a different data. So for here, we are passing a line, and which is essentially like a raw string, and we are using that to just parse it back to our type save data class, which is like move over here.
I'm just gonna put this one on a couple of lines here so that maybe it's a little easier for people to read. Okay. And then we could even zoom in a little bit. Okay. Yeah, so it's the splitting, and then you do a filter index. This one you gotta explain. This one, it takes... Now this one you gotta explain.
Yeah, actually, like I wanted to do, this was like a crazy hack which I just put together, the filter index one, but I actually wanted to do something like, take the line, filter it if it is a digit, and then just like, instead of like splitting and doing all this stuff and doing all this math, I wanted to just check where the digit is and get those characters in, because we know the position of them.
Okay. And then you just map that to an integer, and you actually create this one. And I guess because you wanted to have it all in a single line, you use a let here. Okay. Which just gives you the result of all of this inside the block. If I actually put this one on a separate line, we can see that it's added as the implicit receiver it here, and then you just index into that, and you do your offsets here. If we look here again, the first one is the quantity, so that was gonna be like move 3 by from and to, so that's your source and target. Okay, so I'm curious if you have a strong opinion, because and we'll see this in a little bit as well. instead of doing the conversion using an off function, I like having an extension function on string that's like 2. So I would have something like string to move, which in this case is essentially just a move of this. Do you have a preference for either one?
Yeah, like I feel I feel the companion object is much better because it's kind of like bound. So this with an extension function, anyone can call this string.toMove, and there might be a failure or anything in there, unless like you were using like move.off inside the string.toMove. Also, like if you have like a lot of modules, I think this is like for large projects, but if you have a lot of modules, the auto completion and stuff might slow down because you have this global extension function like which is converting any string to move, and I feel that like that's like a scope. It's a bit out of scope. Like you don't want everyone to open like any string to come here and try to be converted into to move. And
Yeah.
versus with the companion object, the person using the move data class is trying to we are just like actually like giving them a helper function, right? Like to build a move object. So they definitely wanted to create a move object compared to like so they know what they want, and like I feel with the extension function, this specific one, it's like open to everyone.
Yeah. And I think that's perfectly valid. I'm seeing here also Jonathan Kohlberg also agrees. If it was not advent of code, I would not write an extension function on string or other primitives. Yeah, of course, with this function, you are kind of quote unquote polluting the string namespace. You're adding more functions there. You can of course scope these by making them, for example, private if you only need them here. But of course, if you want others to create this as well, then that's something where the off function makes sense. Now I think we saw one of our previous guests also introduce the fact that you can have a capital M move function instead of just having another constructor one, where you could also have an input string, and that one could of course also return you a move of the string. That's also something that is valid and that you see people do sometimes. I think the compose folks and stuff are doing this, but of course what you could also just do is do a secondary constructor. All of these are they all have a little bit of a different flavor to them, I guess. In this case, I kind of like the off naming because it indicates a little bit that there's some parsing or some data mangling going on. You're not just calling a constructor. Yeah, so this one I like.
Yeah, the other name, like some people also like to call it as from. So like move dot from and then the line kind of like also makes sense because you're making a move object from the line.
Yeah. So that, I mean, those naming schemes I think are pretty interchangeable. Estiu says, could you type alias the string and add an extension method on the type alias, or do I need more coffee? So as far as I know, I mean, we can, I guess, try this. I'm not sure. Type alias the string. So type alias move string is a string. I guess we could do this, but I think the problem is that if you're writing an extension function on move string, this is going to straight up desugar into your regular function. So you can absolutely just take a string literal and call to move, even though it's defined on the alias. The problem with this is because type aliases are like, they don't introduce any kind of safety. What you can do is you could introduce an inline class or a value class, but then you would have to wrap your string class always into this value class. It doesn't add overhead, but at that point you're already, at least like from a code perspective, you're kind of constructing an object. Like then you might as well just construct this one while you're at it. I don't think you're gonna win much from that. Okay. Man, we got sidetracked hard. Okay, so let's go back down here. So with the stacks populated and the moves all added to your move list up here. I'm wondering if are you actually going to be modifying your move list later on? I feel like otherwise maybe you could even avoid having this be a mutable list.
Yeah, that's a good point.
Like,
Oh no, I think it's mutable because we wanted to fill that list with all the moves. But you're right. Like we could potentially, like, if you look on 987, that's where
if we take this one, I think we could
I
probably
think that
just
could work. Yeah,
do that.
I think that's even better. I would recommend this one.
Look at that. Hey, we live coded it. This is now officially a live coding live stream. Wonderful. Okay. And then we just get the moves, and then we perform the moves. Okay, so for now we're just gonna look at part 1. And then we'll look at part 2 after we've discussed this one. Okay. So, what's going on here?
Sweet. So yeah, we at this point we have all the stacks, the moves. So what we do is like we map it to the array DQ, which we are using as a data structure for this, and convert it into a list, and passing it to part 1 to like perform the actual calculations in there.
So I'm thinking, or what I'm seeing here, because you already have your list up here, what you're essentially doing is a defensive copy, right? Like you're making sure that you don't modify this one because you're expecting to be reusing those stacks down in the second part. Is that right?
Yeah, that is correct.
Okay. And why is the toList call needed here? I'm not sure this one is actually needed. I think this should be just as fine.
I think that should work. Yeah.
Hey, saved another little bit. That's perfectly fine. Okay, and then we'll look at the actual evaluation. This one we're gonna also. There we go. Fits perfectly on screen. Before we do that, real quick question here: is array deck in the Java standard library? It's in the Kotlin standard library, and that means you can as long as Kotlin's in your project, I think you can even use it from your Java code. But most importantly, you can use it in any Kotlin project whatsoever. Okay, so part 1, what's happening here?
Awesome. Since we have like all the moves now, so which are like also like type saved. So what we do is like we iterate on all these moves. So like on line 44 in the map, we get the first move. And depending upon, so right now each move contains the quantity, the source, and the target where the crate needs to go to. So we essentially like for that quantity, we perform the step act that is like moving from source to the target, and that's we do the add first, and we add the source.
Okay, so as the parameter, you take the remove here. So I guess if you're thinking about it not in terms of a deck, but in terms of a stack, you're kind of popping an element of the stack here, and then you're pushing it onto the other one, which is kind of the motion that you get from your crane.
Yeah, correct. That is the exact one.
Okay. And then at the end, what you do here, if I'm guessing, is you're just taking the top elements and you use join to string.
Joining them.
Nice. Okay.
This is just to get the value which you want to show to the else.
Okay. Yeah, exactly. What we need to deliver. Very cool. I'm thinking actually looking at this one, since you're not using the output of moves, I think this one could also be a for each, right? Correct. That's the only thing that I'm seeing here. But apart from that, okay, that gets you the final the final result. And then
Yeah,
if we
I think it
run
could
this,
also be a repeat. I mean, it's the same thing, like a repeat or a for each, like um, a repeat function which takes in the moves and then we do it.
yeah, that's also true. So yeah, and then that gives us the hopefully the same word as that I did here. Okay, cool.
Yeah.
Wonderful. Look at that. First part solved. Nice. How hard would you say was this for yourself? How would you rank this one?
I think it was like 6 or some 6. If 10 is the hardest thing, because for a second it kind of fooled me. Because when I started, that's why like I needed to use if you look at how I'm filling the values of the stack in the code, I'm doing like index divided by 4. If you screw, that one. Because like when I started like with the reading the lines, and then I got these values, I was super happy. I was like, okay, I'm getting all the stack values, but then I don't know which stack those values need to go in, and that's why like it went from like 5 to 6, kind of like on a harder scale. Then I like, okay, then I came up with this hack of like divided by 4, which was like a band-aid on the already a quick idea of just getting the values.
Yeah. I think that's a fair assessment for this one. I think that's very valid.
How would you rate this one?
I mean, this one, it felt like, it didn't feel too hard, but it felt kind of like cumbersome. Like it felt involved.
Yeah.
So I'd probably rank it somewhere around a 4, maybe a 5, depending on how I'm feeling. Yeah. But of course, we are not done yet. I'm putting back on my reading hat. There's more. There's more stuff that needs to happen here, because as you watch the crane operator expertly rearrange the crates, you notice the process isn't following your prediction. Some mud was covering the writing on the side of the crane, and you quickly wipe it away. The crane isn't a Crate Mover 9000, it's a Crate Mover 9001. The Crate Mover 9001 is notable for many new and exciting features: air conditioning, leather seats, an extra cup holder, and the ability to pick up and move multiple crates at once. Again, considering the example above, the crates begin in the same configuration, but moving a single crate from stack 2 to stack 1 also behaves the same as before. However, the action of moving 3 crates from stack 1 to stack 3 means that those 3 moved crates stay in the same order, resulting in this new configuration. We got D, N, and Z, which now move D, N, and Z, which is the opposite from what we got beforehand. Next, as both crates are moved from stack 2 to stack 1, they retain their order as well. So from stack 2 to stack 1, they're just moving. We got C and M, we got C at the top still. And finally, a single crate is still moved from stack 1 to stack 2, but now it's crate C that gets moved. Yep, it's the top one, gets moved over. Nothing surprising here. In this example, the Crate Mover 9001 has put the crates in a totally different order, MCD. Before the rearrangement process finishes, update your simulation so that the elves know where they should stand to be ready to unload the final supplies. After the stack rearrangement procedure completes, what crate ends up on top of each stack? Okay, so we got a little bit of an extra challenge. Where did your mind go with this one?
Yeah, I think so. What I got from it is like the crate is now much better and it can move 2 crates at a time, right? So my initial thought was like just to do one more operation when I'm doing the move, just doing like one more time, something like that.
Yeah, but at the end it seemed that kind of it's not just one more, right? It's an arbitrary number more. More elements that it can carry like in the same. But we'll see how you implemented it here.
Yeah.
So walk us through this. Seeing a lot of map functions.
Yeah. Again, like same like the part one, we take all the moves. I think this again the map can be for each since we are not using its value.
Sure.
Um, the 949. And here what we do is like for every move, we we uh, once we have the move, we get the source, and from where we want to move it, and so we do a sub list. So we take how many quantities we can move. So let's say we can move 2 crates or 3, um, and then what we do is like we do a reverse. So we maintain the order, and then in the map what we do is like we get the value, we get the
Uh-huh.
target, and we add our value in there, the first value.
Uh-huh. Okay. That's clever. Um that's kind of fun because yeah, you're grabbing a bunch of them and
Yeah,
knowing that you took this one quite literally. You weren't like, "Oh, they stay in the same order." You just said, "Well, compared to the first one, now they're backwards. So if I just want to stack them individually, I just got to reverse them first." That's a cool move. I
yeah.
like that. And then for each one of them, essentially, I guess these two could even happen inside the same, like for each statement. These,
Yeah, I think we could do that, like just within the line 51, just
yeah.
add and
So
then
this
remove
one,
them. Hmm.
since if we don't use the output, we could probably write something like this, and we'll move this whole part in here, and that I think is pretty much the same idea. Which, yeah, I think the sublist idea is kind of clever. I had to
Yeah, I
do it
think
a
the
little bit different.
sublist is the key over here, for this one.
Nice. Yeah. So was this something that, when you saw the problem, you were like, of course, easy, just a small adjustment, or did it kind of throw you a wrench?
Um, it did seem like a small adjustment. Initially, like I took the part one and started like doing what we are doing in the for each right now, like just
Hmm.
doing add first and remove first, and that didn't work. And then the sublist idea came to my uh, rescue. But yeah, I think I would say it was like 5, considering we had the part one already like established at this point.
Hmm. Yeah. Okay. That I think that's very valid. We'll look at my solution real quick here and my assessment. So spoiler alert, this one is gonna be pretty similar. It just has a couple of parts that are slightly different. So first of all, just gonna make sure here this is the right one. Yeah. So for day 5, we just kind of still read our input string, and I've decided that the kind of initial stacks, or that we would kind of split this based on the 2 new lines that were in the input. So if we look on the input, there's one like empty line. I was like,
Yeah, that's a
okay,
clever one.
yeah, okay, this part is clearly the first part of the instructions. This is the second part of the instructions. I remembered this one just from day 1, when Pavel said, "Yeah, we can just split on 2 new lines to kind of get the groupings." This is kind of the same approach. So I split these up. I use my destructuring declaration to kind of turn these into 2 separate variables, and then I start with the parsing work. So first of all, we're looking at the kind of initial stacks, right? So just kind of what they are described as in this configuration, which at first I just treated as a list of chars. In this case, what I did here is I kind of went a little bit more lightweight than usual. First of all, I got rid of the first line. I got rid of the last line because that was just the numbers. I didn't need these one for creating the stacks. I reversed them because I wanted to build things from the bottom to the top, right?
Makes sense.
I didn't want to start with these ones up here, and then I mapped these into what I call to crates, which is getting out the actual letters, or getting out nullable letters. Now, I've seen a couple of... I personally like the step 4 function that someone mentioned a little bit better than my solution. But what I did was I used the chunked function, because I am a big fan of chunked. What I just do is I take the input string. I have to add an extra space at the end of each line, so that each kind of element is like this, right? It's an opening paren, then it's a letter, it's a closing paren, and a space.
And then a space.
Yeah. So now all of these are kind of consistent. They all have this shape, which means after I've done this, I can just take these chunks of size 4, and I can split them, or I can take out the letter if there is one, and if there is nothing, or if there's no letter, which means we've probably hit one of those empty spaces, then we'll just return null. Yeah. And of course, this is kind of just the initial configuration. What I also needed was a data structure to store things in. And just like you, I used an array deck because I was suspicious on whether this might not just be a stack, but maybe they also have something where things shift, or where I need to add something at the bottom of the list.
Mm-hmm.
Yeah. So I decided I'd also go with the array deck. I'm now just calling this pulling a Todd, because that's what he kind of did last time. I saw that it was 9 elements, so I wasn't gonna bother with parsing this. I just hard coded as 9 elements. That worked perfectly fine. Yeah, and then I'm just filling row by row. Remember, from bottom to top, I am filling each of these stacks with the elements that I found, skipping any elements where there's no crates in anymore. Here I was very, this is, I guess, very lucky that these are all stacked and that there's not like one floating here. That would have given me a bit of a problem. Yeah, and with that filled, I also made a defensive copy, just like you did, just using the map function, just kind of create a deep copy, so recreate all the array decks inside, and then let the map function do the work of creating a list that's around it. Yeah, and then of course I still had to parse the instructions, and in my case that meant using a 2-instruction extension function. We've discussed at length whether this is a good idea to do on string or not. Maybe it should have been instruction.off. Who knows? But yeah, here nothing very creative. I just split the word on spaces, because I can copy one of these in here so we can kind of see the first word, quote unquote, or zero's word is move, then the first word is 3, which is the count, then we skip one again, then at index 3 we get the from, and at index 5 we get the 2 here. Now I wanted to be a little bit clever, and I wanted to say, okay, my words are I wanted to split them like this, essentially. Give me 2 seconds here. Let me just comment this out so we're not looking at a bunch of red code. Because I was like, of course, we can use a destructuring declaration, right? So I was like, we have move, which we can ignore, so that could be an underscore. Then we had count. Then we had from. Then we had, sorry. So then we had the from word, which we ignore. Then we had the actual from. Then we had 2. And then we had the actual 2 value. Now, the problem with this one is that we don't have enough extension functions on this one. List of string does not have a component 6 function built in, so I didn't want to do this one. I guess I could have just created one for like lists, and I could have just created a 6th one. That would be fine. But I decided, this time around we're gonna do it with the built-in functionality and not start introducing extra vocabulary.
Yeah, but I think this is still clever. You're splitting it.
Yeah, I'm a big fan of the split function. I use that all the time. Yeah, and then I just have the instruction objects have a function called execute. Originally I called it execute, and then after the second part I call execute as part 1, which just takes one of these stacks or stack groups and starts mutating them. So if we look inside this one, all it does is, so essentially you take every instruction, you stuff in your thing that you want to mutate, it mutates it, then you take the next instruction, you stuff it in, it gets mutated a little bit, and that's how you end up at the end. So each one of these instructions just gets this information. Of course, because of natural numbering, I needed to do an offset of -1, but then it's pretty much the same as we've seen in Akshai's code. It's just a remove last and then an add last, and I called my intermediate method in the crane claw because that's kind of how I think about this.
Yeah, I like the naming. Really good in the crane claw.
Yeah, and then of course the output is almost the same as Akshai's. I do something a little bit different because the join to string function also takes a lambda, and this lambda kind of determines how an element is represented as a string. So you can kind of think about it as the map and the join to string kind of in the same thing. The only trade-off you have to make is this one always has to return a string versus your join to string, if it's on an arbitrary collection, it's gonna call to string itself. So you're gonna either have this or I guess you're gonna have it.last.toString, and either of those are gonna work. I just like this because it meant one less method in the call chain here. Okay, and then secondly, for the second part where we had to change this around a little bit, I didn't come up with a very clever solution because I think someone else also messaged it or someone wrote it in the chat. They were really looking for like a pop last or like remove last of n, like remove a bunch of them at once, like remove 3 of them. But unfortunately, that doesn't really exist. The sublist trick is a good one. In my case, I'm just doing the following. I kind of fill my crane claw with a copy of them, so just take the last couple ones. Then I remove all of them with a loop. This part is, I think, the nastiest part of the whole thing because removing last elements in a loop I really don't like. And then I just go through all the crates in my crane claw, and in the same order that I got them out of the stack, I kind of add them back in again. So what's important to know here is that take last, it goes still in the same order of your input collection, right? So if your stack is at the bottom A, B, and C, then if you take the last 3, it's still going to give you A, B, and C. So if I add those on the other stack, when I stack them on top of each other, the order is maintained. Yeah, and with that, I do the same join to string, and that also gets me to the end. Peter says sublist. Yeah, we've seen over here. I can show this one again. In Akshai's solution, he used the sublist and then reversed the elements, and then just kind of flipped each one of them on the other stack, which I think is also quite elegant. Yeah, there's a couple more comments here. Let's see. For info, lines makes an extra allocation than split. Okay, that's interesting to know. Yeah, map, and then so this is Kaloyan post. This one we can definitely put on stream just because it looks very delightful. Uses a regex and then a find and then a group values and then a drop and then a map. So I guess that's also an approach of.
I was looking for something like this, like a regex. But yeah, it needs like I always forget all the regex rules except the basic ones, the character and the digit stuff like that.
Yeah, I have to say I only grab the regex when I have to. I, as long as I can afford it, I like going with a simple split function. But when there's more involved symbol shenanigans, I think we're not gonna get around regex. I think Todd also mentioned this yesterday, and I don't think he was wrong with this one. There's gonna be one that's regex heavy. Yeah. Nice. Okay, let me see here. I hate regexes with a passion. It's write once, read never. Yeah, very valid. It's write once and then pray that it just works. But yeah, hopefully, your regexes will all be Christmas miracles.
That said, like I don't know if you guys know it, but in IntelliJ there is like a feature if you write a regex and the autocomplete command. Oh no, I think it's like an options command. In there you can see there's an option for check regex, so you can like in real time check it. So
yeah, so
Sebastian, if you
I'll just do that here real quick. So first of all, if you're using a raw string, always a good idea for a regex, because that means you don't need to escape your regexes extra if you have escaped characters in here. And then if you press Alt Enter or Option Enter or Option Return on Mac, there's this check regex functionality, which gives you this little pop-up, and then you can see if 1, 2, 3, for example, fits it. Yeah, which is quite elegant. We can see that 1, 2, W also fits it. Just a couple of spaces doesn't fit it, so we get the little exclamation mark. Couple of dots doesn't fit it, even if we add, or only if we add the numbers, we can see that there's a partial match here. These kind of things. So yeah, this is definitely quite useful, especially. I didn't actually know. I think they recently added the fact that it shows the which part of the string matches. I think before it was just does it match, does it not match.
Yeah, I think that's a new one.
Yeah. But hey, look at that. We're ever evolving. Isn't that nice? Well, you said it was your first time doing Advent of Code, so my question is, of course, are you going to come back tomorrow into Advent of Code? Are you going to solve another of these challenges?
Absolutely. This is really fun.
Nice. Then you are, of course, in good company. If you are taking part in Advent of Code 2022 in Kotlin, and you have not added yourself to one of our leaderboards, we are now up to 5 leaderboards, then please make sure you add yourself. All of this is linked in the description on YouTube, and of course also if you can find the blog post, otherwise that's gonna help you there. There's also, of course, our GitHub repository template in there. If you want to take a look at that and just kind of see, it's a quite basic one, but it has the important part in it, where it gives you the important hint that if you want to win something, you got to make sure that the AOC 2022 in Kotlin topic is attached to your GitHub repository, and that you have some form of contacting you in your GitHub profile. Otherwise, we can't send you the exclusive t-shirts and the exclusive stickers and other surprises that we have for this very campaign, because they're physical items and we need to contact you. But yeah, we can also still have a quick check-in here. See a couple of people in the leaderboards here. Congratulations to Nikita, Michael, and Nikolai, who are on our first leaderboard, quite up there. Liquid Fun, Jacob K, Brigham, another couple. Then we got Ryan Eccles, and we got me. Hey, hello. Daniel Wright. We got Christopher Olsen, Kelly Dance, Joe Nace, and now in the latest one we got Gropeb, Lucifer, and Roman Yelizarov. That's right. You're in good company here. So yeah, if you want to see if you can beat Roman tomorrow, and you haven't joined one of the other leaderboards yet, actually let's have a look here. Yeah, no, this one's already full. But yeah, you can take a look and you can measure yourself with the best. So Roman, language lead of Kotlin, is of course also gonna come on this show on the 8th But tomorrow, our surprise guest is going to be Anton Ahipov, our very own. Now it's not a surprise anymore, but I think it's a very he's a very cool guy. One of my fellow developer advocates who has participated in Advent of Code for quite a while. He's done a couple of videos. If you want to prepare for what's to come tomorrow, make sure you check out the previous recordings that we have on YouTube. Take a look there. And maybe you'll even learn something that's going to become weirdly relevant tomorrow. I'm not saying we can predict the future, but, you know, who knows? It might still help. All right. Okay, well, actually, thank you so much for coming on today. I had a lot of fun.
Thank you for having me.
Yeah. It was really good. I'm glad that I've got to stack a couple of crates with you. So,
yeah.
Exactly.
And help the elves.
That's right. We are saving Christmas after all. Okay, with that, we're going to sign off. And I, of course, hope that we'll see you again tomorrow at the same time with another challenge. So yeah, take care, have a good one, and tune in tomorrow. Bye, everyone.
Bye-bye.